have digested these samples, 12 samples. So today the sample cleanup should be there. It is mandatory steps for proteomics and also for LCMS. So this is the vacuum manifold where the sample cleanup is going on. This creates a vacuum and pull down the solvents. These are the cartridges, C18 cartridges. There are 12 probes, so at a time 12 samples will be cleaned up. Sample cleanup is mandatory because there are impurities in the samples that has to be eliminated before injection into the LCMS. Otherwise, it will create some problem, like the peaks of impurities will come along with your sample. It may clog the column. It may harm the instrument. So, it is recommended that before sample injection, the digestive sample has to be cleaned up. Though this process provides sample loss, but this is the mandatory and recommended step for mass spectrometry. So for cleanup, we have to prepare some solvents like activation buffer, equilibration buffer and elution buffer, and there are 4 to 5 steps in this process. The first one is the activation, which is done by the activation solution, which is 50% methanol. Then comes equilibration, then comes sample binding and sample loading, then comes washing, then elution. So this step is now going on, the equilibration. These C18 cartridges are dried first. So this is the C18 bed, this whitish portion. So at the very beginning, these columns are dried. So we have to activate and equilibrate before the binding of the sample. So that procedure is going on. Here we use 1 ml of solution for each tube and thrice per tube. Activation solution, equilibration solution, washing, as well as elution. For elution, we are eluted in 600 microliter. That is also step gradient, 200 plus 200 plus 200, not at once 600 microliter. After this step, the sample loading will be done. creates the pull down. The tubes are going, the solvents are going down, and when they are empty, the valve should be closed. So now activation and equilibration is over. So I have to tighten this valve. Now next step is the sample binding. Washing step has been completed. Now elution is about to start. The samples get bind to that column, and now we will elute the samples from the column. The elution solution composed of 80% acetonitrile with 0.1% TFA. This TFA and FA or formic acid acts as modifier. What is the function of this modifier? I will tell you later. So now this has to be pulled down. Yes. By losing the valve, the solvent along with the sample that binds to the column getting down and collecting into a new Eppendorf. And after this, we will put them into speed vac for drying. Elution is 12 samples are there. We have to elute in 600 microliter, but not at a time 600, 200 plus 200 plus 200 for step gradient, or we can call it manual gradient. This is the last step of sample cleanup. Process comes to an end. The cleanup process is done. So we have to tighten the valve. We eluted the sample in 600 microliter, and now we go for speed vac for drying. So the elution was done. The sample is now ready. The elution is in 600 microliter. So now this is the speed vacuum. Here the samples are now dried. The time depends upon the solvent that how much it will evaporate. So we generally find that it took 4 to 5 or more than 6 hours for drying. So this is the Eppendorf speed vac concentrator class. So here the temperature is room temperature, the aqueous medium, the setting is there, and now I will put the samples into this rotor and start the instrument for drying. Now the samples, I kept it in the rotor. So there are few more samples of yesterday's preparation, so they are little bit left for drying. So sometimes I find that the drying should be continued to next day also. So for these samples that is occurred, so they are not fully dried, so I have to put it again for fully dried. So now I will close this lid and start the vacuum. So this will take time, and this is how the sample cleanup is being done. After this, the dried sample has to be reconstituted in the reconstitution buffer. Then there will be protein estimation, how much peptide or protein left, and after that we will inject into the instrument. The estimation is necessary because the analytical column in the mass spec, there is a limitation of sample injection. Less than 1 microgram sample to be injected for to maintain better column life. So we have to inject around 650 or 750 nanogram, which is less than 1 microgram, and for this reason the estimation of proteins after digestion is necessary. So there are 2 times of estimation: before starting of the experiment, how much protein you are taking, it is necessary, and after digestion and after cleanup, it is for the injection purpose. So you may find there is a concentration difference between these two, because in the sample preparation, or in the better to say in the sample cleanup process, around 50% sample loss is there. We have noticed it. So that's why the difference in concentration will be noticed. So thank you for today. Next we will discuss the sample injection in the next video. Thank you.